VNets which we have shown in the diagram. So let's have a more closer look on the diagram. As you can see here, there are two web servers which are deployed in VNet 01. We are going to deploy in one of the subnet called DMZ subnet and in the Central India region, and we are going to put them in the availability set. With the help of the availability set, we are going to guarantee that these servers are available irregardless of the fact that if one of the zone goes down inside the Central India region. So the availability set will guarantee the protection against the zonal failures. Then we are going to enable the SRM. So when we are going to enable the SRM, there are multiple options possible. We can actually do the SRM implementation for one instance, or we can do the SRM implementation for the whole availability set. In the bottom part of the design diagram, you will see that we have another region which is somewhere in UK, and in that particular region we are going to deploy our application load balancer. So why we have deployed the application load balancer in a separate zone? There is a reason for it, and the main reason is that of course if there is a regional failure in Central India, we're only going to lose these two web servers, but our application server load balancer will be still available, and it will be start pointing to our DR site web servers for which we can do the site recovery using ASR. There is slight variation in the design again possible. If you look into the option number 2, in option number 2 what we have done is we have deployed the application load balancer in Central India region as well as in East US region, which is our DR site, and then we have to deploy a traffic manager which can redirect the traffic to one of the application load balancers. So this solution become little bit more expensive, because now you're actually running two instances of the application load balancer, and you also have to deploy the traffic manager. But in some cases this solution is more realistic in terms of disaster recovery approaches, because in this case we can use the same application load balancer in the East US region to serve any test environments, development environment which could have been deployed in the East US region. But right now we are going to do this testing because our demo is more focused on how to implement the ASR and how to do site recovery using ASR and site failover using ASR. We are going to follow the option number 1, design option number 1. Now it's very important to note down that this VNet 01, which we have shown in the diagram on the left hand side in Central India region, has a subnet of as an IP address scheme of 10.1.0.0/16, and when we enable the VNet 01-ASR is not the VNet which we have created manually. It will be created automatically by ASR when we enable the replication of Web 01 virtual machine. And you will note down that when we enable it, the VNet 01-ASR will have the same amount of subnets, same IP address scheme as we have on VNet 01. So VNet 01-ASR would be 100% a replica of VNet 01. And definitely we cannot do a VNet pairing between these two, so they have to be isolated VNets. And that's where this application load balancer, if you have deployed in a separate VNet, will also help, because in case of the actual disaster and Central India goes down, the application load balancer, which is sitting somewhere in separate VNet 10.2.0.0, can still communicate with our VNet ASR. Of course, we have to do the VNet pairing between VNet 02 and VNet 01, and we also have to do the VNet pairing between VNet 02 and VNet 01-ASR. So let's start our implementation. What we are going to do for the first time is first we will start with the with logging to a portal. First of all, we have to do, let's say, we have to create the VNets. Let's create the virtual net first. Okay, so we have a resource group called test RG, so we're going to deploy all of our resources in test resource group. We call it VNet 01. We'll deploy in the India region, Central India. So Central India region would be Central India region. Security wise, we want to enable the Azure Bastion on this one. We can call it VNet 01-Bastion. We have to create a public IP for it. So let's call it pub IP. Okay. Now we're not enabling the Azure firewall, or we're not enabling the DDoS protection right now for the simplicity of this demo. So we have to create 10.1.0/16. Now here you have to modify the subnet IP address scheming. So here we can say it is the first subnet, we call it, let's say DMZ. We call it 10.1.1.0/24, right? So this is our DMZ subnet. And the Azure Bastion, we can go with 10.1.10.0/26 is more than enough for us. It's because it's only require few IP addresses. So 10.1.1.0 would be used for DMZ, and 10.1.10.0 will be used for Azure Bastion. We also want to add another subnet. Let's add another subnet for application gateway, because we would require another subnet for this one. So let's say call it 11.0. We can also go for /26 for it. We don't require a big subnet, so /26 is more than enough. So we call it app gateway subnet. So we have deployed DMZ, we have deployed Azure Bastion subnet, we also deployed app gateway subnet for our application gateway. Let's put some tag here. Let's put the tag. Okay, and that's it. So we're going to deploy this first of our VNet. Okay, so our deployment is running right now. So we're getting first of our VNet with our subnets, DMZ subnet, Azure Bastion subnet, and the application gateway subnet. So let me pause the video and then come back once the deployment is finished. Our next step is to create the Bastion service. As I said, Bastion will allow you to connect to the VMs without having the need of having any public IP on them. So we can create the Bastion, but before we do the Bastion, let's go and create another VNet, because we need another VNet for. Let's create another VNet as per our design. We will put the test RG, and this time we are going to put it in the UK region. So this will go in our UK South, and we call it VNet 02. Security, we don't require any Bastion service on it. We don't require any firewall. We only need is because we're going to deploy the IP load balancer, the application gateway. So we have to create a subnet here. Let's change the IP address scheming for it. For example, 10.2.0.0, and you can call it app gateway subnet UK. And we can call it, let's say, starting address could be 10.2.10.0/24 is enough. Okay, so let's create this one. tag, we'll just put the same tag. Okay, so we create the VNet02. Okay, let's create it. So now we have our VNet01 and VNet02 being deployed. We have deployed in Azure UK South. So let's go back to our VNet0 is being deployed right now. It's already successful. So now we're going to create two of the VMs in our so this is still going on, so we have to wait. So let me pause the video, and I'll come back once the bastion is ready for us. Okay, so our bastion deployment is complete, our VNet deployment is complete. So let's go and check our implementation so far. So we have two VNets here, VNet01 and VNet02. VNet02 is actually in UK South, and VNet01 is in Central India. In VNet01 we have deployed multiple subnets. I don't think we require application gateway subnet, so I'm going to delete it because we don't need it in India region. We are going to do it in UK South region. So probably I'm going to delete this one. So app gateway subnet is deleted from VNet01. So we have only one DMZ and one bastion subnet, and that's more than enough for us for today's demo. So if you go to the VNet02, that's in UK South, we have the subnet for the application gateway, for hosting our application gateway. So let's go and create the two VMs we need. Before we do that, let's create the private DNS zone first. So private DNS zone will help us in giving the fully qualified domain names on to the virtual machines which we are going to deploy. So it will be easier to use the host name instead of the IP addresses, especially when we are configuring the application gateway for the backend. We will use the host name instead of using the IP addresses. So we can call it testlab1.com. Okay, and then tags is the same tag. Okay, so we're creating a private DNS zone, testlab1.com, and we create it. So private DNS zone deployment is in progress. We'll pause the video and come back once the deployment is finished. Okay, so our private DNS zone deployment is complete. It's called testlab1.com, but we have to define the virtual network links to this private DNS zone. It will be a private DNS zone. The virtual network link will actually allow the virtual nets or any resources, any VMs deployed in the virtual nets to use this private DNS zone. So let's go and define the first link. We can call it link to VNet01. Okay, and we will say VNet01, and you also have to enable the auto registration so that any VM which we're going to deploy in VNet01 will automatically get its A record created in testlab1.com. Okay, so we got the first link. Still working. We have to wait. Okay, so this is in progress. Let's add another link. We can call it link to vnet02. Basically the link to vnet02, where vnet02 is the one where we are going to host our application gateway. So that's vnet02, enable auto registration. So now both of them are in progress. So we'll wait, we'll pause the video, and we'll come back once this vnet link creation is done. Okay, so our vnet links to vnet01 and vnet02 is completed from the private DNS zone. So now I'll go back and start creating our virtual machines. Now the virtual machine we are going to create in vnet01 in our DMZ subnet. So let's select the test RG. We can call it as per our design web01. It's Central India region, and we are going to put in the availability zone. So if I put in the availability zone, I have to select at least 2 zones. So I'll go in zone 1 and zone 3. We don't require the now here basically for the image, because we want to run the IaaS on top of this machine. So in order to avoid the time of manually installing and configuring the IaaS, we go to the marketplace and search for any appropriate image which contains the IaaS. So let's search for IaaS images in marketplace. There are multiple IaaS images available. IaaS on Windows 2019, 2022. So we can select any one of them. They are free. So let's select this one. Okay, so we have web01, and actually we have to change. We want to change the name to match our design. So we can call it web01. If you see that it's a copy of web01-1, it's called web01-1 because we're putting in the availability zone. So basically it says that it's essentially web01, but it -1, which is basically the first VM in the availability set. Then you have the web01-2, which is the second web server in the availability zone. But if you want to name it differently to match our design, we can call it web01 and web02. So 2 VMs in the availability set. First server is actually in zone 1, second one is in zone 3, and we are deploying IaaS, right? So here I'm going to choose the B2S, which is most appropriate for most of the demos. We'll put the username here. Okay, for the disk we'll go with the standard HDD for this demo. Networking. So because we have selected the images from the marketplace, these marketplace images unfortunately comes with public IP by default. So we have to accept whatever it is. But what we can do once the VMs are deployed, we can go back to the VM, shut down them, and detach the public interface, because we don't want our public IP addresses to be exposed. The only IP which is going to be exposed on our design, as per our design, is the public IP, which is this one, and this is the one we're going to expose to the internet. The VM themselves should not have any public IP assigned to it or exposed to the internet. But unfortunately, it is coming by default, so we can leave right now. We can come back, shut down them. Once they're deployed, we shut down them and then detach those public IP addresses from the VMs. The rest is fine. Right now I'm not putting them under the load balancer. I will separately add the application gateway, as we know that in the UK region. So it's fine. Monitoring advanced, we just put the tag here, and just go and review and create. So now we are going to get 2 IaaS servers, and they are actually in one availability zone in Central India region, VNet01. As you can see here, we're getting 2 VMs with 2 public IP addresses, and they are in Central India region. Availability option is on 103, and then we are select IaaS, and we're going with standard HDD for now for this demo, and that's all looks good. So let's go and deploy these 2 web servers. So the deployment started. I will pause the video and come back once the deployment is finished. Okay, so our VMs are ready, up and running. Both of them have been deployed in Central India region. Both are actually in the resource group called test.rg. And let's go on Web01, try to connect there. Again, we have now Bastion available as well, so let's try to use Bastion to connect this one. First thing we will do is we will detach the public interface for it. Let's connect to it first and then see whether we have IaaS up and running or not. So the machine looks fine to me because as you can see we have IaaS here, and what we can do in the IaaS is we can rename the website. We can there is actually a directory called cinitpub. So what we are going to do in this server is that we go to the cinitpub. This is the directory where it stores all the default pages for the IaaS, and there is a directory called www.root in there. So this is the file which actually being run by the web server by default. So what I'm going to do is I have another on my laptop. Basically there is a file over there which I can use it for showing the server host name. So what I'm going to do is this IaaS start.html file. I'm going to upload this IaaS start.html, copy over this IaaS start.html to my cinitpub www.root on both of the web servers, and then rename it to IaaS start.html, so that when we are actually going to the web servers, we should get the host name from those web servers, so that we know that which server we are hitting. So let's do that. I'll pause this video and then I'll just copy over the files and we go from there. So as you can see here, I just actually updated the file. If you open it with the notepad, you will see that it's just showing the web01. It's just showing the host name of the server as web01.testlab.1. That's a testlab1.com. If I open it with a browser, let's say for the Internet Explorer, we're getting the desired output. So what we're going to do it is we'll just go to the cinitpub directory. We'll just go to the cinitpub directory, and we'll copy over this file here. We will rename this one to IaaS start.2. And we will rename this start1 as our main file, which is IaaS start. Okay, so now we have changed the content of the web service. So basically, if you go to the IaaS service manager, it would be good if you restart the IaaS service after these changes. So you can go to the sites, you can call it Web01 for example, and then you just stop the service, the IaaS service, and then just start it again. So after you restart it, you can try to browse it and see what happened. So it's working fine. As you can see, we are getting web01.testlab1.com from the server. Now we will do the same step on our web02. The only difference is that we are going to get the page called page should display the name web02.testlab1.com. So I'll pause the video and come back once the changes on second server is done. So now we are going to deploy our application gateway. So as we know that as per our design, we have to deploy our application gateway in the UK region. So let's go and deploy application gateway. So for the application gateway, we're going to test RG and we call it app gateway 1, and we are going to deploy in South UK region. I believe that was the we selected. Yes, South UK region, UK South, and we'll go with the standard tier. We're not enabling the WAF. I mean, we can do the WAF enablement as well, but that's not part of our demo, so we'll keep a standard version 2. And we don't require auto scaling at this right now, so the 2 instances are fine. Now, do we want to deploy in the availability zone? Yes, same like we will deploy in zone 1 and zone 3 of UK region South. Virtual net, we will do the VNet 02, and we also have app gateway subnet UK. So the next step in configuring the application gateway is the front end. So we have to create a public IP. We can call it app gateway 1 pub IP. Okay, then we have to define the backend. So for the backend, we need to add a backend pool. So we can call it backend pool 1. Now, right now we're not adding any targets into this backend pool. We can add it later stage, or we can add it right now. So that's fine. We can give fully qualified domain name. We can say web01.testlab1.com is our first backend, and second target on the backend is web01, web02. Okay, so we will add this one. Then we will do the configuration part, which is adding the routing rule. So we have to add the rule. We can call it rule 1. We can give a priority of 100. We can call it listener 1. Front-end IP protocol is public. Front IP is of course public, right? And the protocol is HTTP. For this demo, I'm not enabling the SSL, so we'll go with the HTTP only. And we are going to add the backend pool. So backend pool 1, and backend setting is a very important part. So we can call it backend setting 1. Now on backend settings, you can also enable cookie-based affinity if you want. So I'm enabling the cookie-based affinity. The rest I'm keeping as is. No changes required, just add it. So now we have front-end IP rule, front-end IP in the backend pool, and we also have configured the rule for this application gateway. Next we'll put the tag. And we're going to create our application gateway in UK South region. So our deployment is started. I'll pause the video and come back once the deployment is finished. Stay tuned. Okay, so our application gateway is ready. Now we have to do the pairing between VNet 01 and VNet 02. And this is important because our application gateway is sitting in UK region South in a VNet 02, while our web servers are basically in VNet 01, which is in Central India region. To allow the two VNets to communicate with each other, we have to enable the pairing between VNet 01 and VNet 02. So I'm right now on VNet 01, and on the left hand side you will see there's a pairing tab, pairing blade. So let's add the pairing. We can say VNet 01 to VNet 02, and the remote virtual network is called VNet 02 to VNet 01, and our virtual net is VNet 02. So the remote VNet 02, and we are actually creating the two pairing links, VNet 01 to VNet 02 and VNet 02 to VNet 01. Okay, and just add it. So this will allow VNet 01 and VNet 02 to talk to each other, and by doing that we would be able to allow the communication between our application gateway and the backend web servers. So I will wait for pairing to, and as you can see the pairing is already completed, it's already connected. So let's go over application gateway, and our backend pool is here. As you can see, one thing we have to do is to two targets are there. One last thing we have to do for our application gateway is we have to add the health probe so that the application gateway can probe the backend servers. To add the health probe, go to the health probe blade. Okay, so now we are on the application gateway. Let's check our configuration. So as we're saying that we have to do the health probe configuration. So let's do the health probe configuration. Let's add the health probe. We can call it probe 1, and we are going with the HTTP, and we are going to give the name of our servers. It's very important that the application gateway should be able to resolve the host name or the fully qualified name of our backend servers. And if you remember that we have defined a virtual net connectivity for VNet 02 as well with our private DNS, so it should be able to resolve it. So path would be our HTML file, which is basically the default file for our web server, and on the backend setting we have to put the backend setting which we already defined. So let's test it. Hopefully we should be able to communicate from our application gateway, which is sitting in the UK South region, back to the web servers in India. So it's not responding back, so let's go back and check what we have done wrong here. Is there anything wrong here? No, I think we're good. It should work. Let's try again. Let's try again and see what happened. Take some time. Yeah, it's all good. So as you can see, our application gateway in South UK region is able to communicate to the web servers in Central India. So let's add this health probe. So now we have the probe also defined, and at this stage we are almost ready to test our design. So let's copy this IP address and put it here and see what the response we get. As you can see, we are getting the response from our web 01. Now because it works on the application load balancer, it's also using the cookie based session, so it's possible that sometime you get the response from web 01, sometime you will get the response from web 02. As you can see here, the same public IP, we got the response from web 02. So it means that the application load balancer on the front end is working fine and distributing the traffic to the web servers in India. This concludes part 1 of our demo, and in the next part of our demo we are going to complete our SRM configuration, and we will also do the site failover and see how the SRM is able to help us in case of a disaster in South